Okay, so let's have a take on amines. Okay, chemical properties of amines. In that we are doing electrophilic substitution of amines. Okay, electrophilic substitution. Electrophilic substitution means positive replaced by positive. Okay, so let's see how we can go about. Okay, so this is aniline because this is an aromatic amine. Okay, so aniline is an aromatic amine. In this, what are we going to do is we are going to perform bromination. What are we performing? First electrolytic substitution, that's bromination. Okay, so in bromination we are splitting this Br into Br plus and Br minus. Okay, Br plus and Br minus. And because this is an electron donating group, it activates the ortho, para and ortho positions of the aniline, due to which if you take 3Br2 you get 3Br plus 3Br minus. So these 3Br and these 3 hydrogens combine to form 3HBr. Okay, combine to form what? 3HBr. Okay, now the positive Br will get attached in place of the positive hydrogen. So when that happens, you get 2,4,6 tribromoaniline. Yes, the name of this IUPAC name of this compound 2,4,6 tribromoaniline. But say for example, I don't want so much of bromination. Okay, what if I want only orthobromoaniline or parabromoaniline? If I want only ortho or parabromoaniline, I should reduce the electron donating power of aniline. So aniline is highly electron donating over here, due to which it is activating the ortho, para as well as ortho positions, and we get 2,4,6 tribromoaniline. What if I want only parabromoaniline? Then I should reduce the electron donating power of aniline. Okay, of the NH2 group. Now how can I reduce the electron donating power of this aniline? By attaching an electron withdrawing group over here. And how do we do that? We react it with acyl chloride, and when we do that, we get one hydrogen and one Cl combining with each other. So we get HCl over here, and this NH will get attached to the remaining part, that is acyl group. So we get NHC double bond O CH3. Okay, NHC double bond O CH3. So remember, this is a very interesting group because if you look at this part, it is amide. If you look at this part, it is aniline. And if you look at this part, it is acetyl. So we are going to combine 3 words. We are going to combine the word acetyl, we are going to combine the word aniline, and we are going to combine the word amide. So acetyl aniline amide. Yes, I'll just change the colors if you want to help you understand. This is your acetyl group, this is your aniline group, and this is the amide group. Okay, so there are 3 groups in here: the acetyl, aniline and amide. So acetyl, aniline and amide together forms acetanilide, and because it is forming acetanilide, listen to me carefully, because it is forming acetanilide, this acetyl group will now reduce the electron donating power. The electron donating power of aniline was too high, that's why it is giving you 2,4,6 tribromoaniline. But now I have attached an acetyl group, which is an electron withdrawing group, and this electron withdrawing group will reduce the electron donating power of aniline, due to which now if you try to brominate it, so bromination will take place only at the para position, because now it's not as electron donating as it was earlier. NHC double bond O CH3, and I'll get a bromo at the para position only with the same mechanics as we had used earlier. Okay, but now I want to shift this back to aniline. So what do? Is we will have to add, say for example, HCl. So this thing will combine with Cl, giving you the CH3 C double bond O Cl. मतलब इसका काम हो गया ना अभी, right? तो इसका काम होने के बाद में उसको टाटा बाय बाय करना है, and here we will have our para bromo aniline. ओके तो सर ये बीच में क्यों अटैच किया था? ताकि इसकी इलेक्ट्रॉन डोनेटिंग पावर थोड़ी कम हो जाए because of this electron withdrawing group, and we get only monobromo, that is para bromo aniline. Getting it? So that's the reason why we had acetylated or acylated the aniline in between. All right, so now bromination khatam ho gaya. Now we'll go for nitration. So in nitration, what are we going to do? In nitration, simply take aniline, react it with 2 acids, that is the nitrating mixture. Who's the nitrating mixture? HNO3 along with H2SO4 is the nitrating mixture. Okay, HNO3 along with H2SO4 is the nitrating mixture. This will split into OH minus and NO2 plus. What is going to happen? This H and OH will combine to form H2O and NO2 will get attached at the para position. See, this is a standard mixture. Concentrated HNO3 and concentrated H2SO4 together are always known as nitrating mixture, used to generate the NO2 group, positive electrophile, which will replace the hydrogen with NO2, so that in this case you get para nitroaniline. What do we get? Para nitroaniline. Let me just write this down. Para nitroaniline. And we also get a ortho nitroaniline, which gives us ortho substituted product, that is ortho nitroaniline, right? Yeah. So now what is going to happen is the excessive H2SO4, right? Excessive H2SO4 reacts with aniline, because at the end of the day, aniline is a base and H2SO4 is an acid. When aniline reacts with H2SO4, this electron donating group suddenly converts into an electron withdrawing group. And because it converts into an electron withdrawing group, you will get, to your surprise, a meta substituted product, that is meta nitroaniline. Okay, we get a meta substituted product. Okay, now you must be wondering that, sir, this is an electron donating group, it should activate only the ortho and para position, then how the hell has it have you got a product on the meta position? Because I told you the excess H2SO4 reacts with NH2. Obviously this is a lone pair, or this is having a lone pair of electrons, it will donate to the H plus ions of H2SO4, and one H plus ion will get attached over here. When one H plus ion is getting attached over here, temporarily in between it becomes NH3 plus. The moment it becomes NH3 plus, from an electron donating group it shifts to electron withdrawing group. Now it starts withdrawing electrons. When it starts withdrawing electrons, the meta position gets activated and you get meta nitroaniline. Okay, that's how you get meta nitroaniline. Okay, so you get all three. This is the only reaction where you're getting all three, that is para as well as ortho as well as meta. In other reactions we usually get either ortho para or we get only meta. This is a reaction where we are getting all the three. Okay, now next is sulfonation. Now this is also an interesting reaction. Here we form a zwitter ion. I'll tell you how. Okay, so in sulfonation we are having, say for example, aniline. You can take any other aromatic amine. So we are using standard as aniline, so we'll continue with that. And H2SO4. H2SO4 splits into OH minus and HSO4, sorry, SO3H plus. OH minus and SO3H plus. So one hydrogen from the para position, H and OH combined to form H2O. Once you get this, there is SO3H group attached at the para position, and when SO3H is attached at the para position, this is no more aniline because the priority shifts to SO3H. This becomes BSA, that's benzene sulfonic acid, and on the para position you are having an amino, so para amino BSA. Para amino BSA. BSA is benzene sulfonic acid. But at the end of the day, this is an acid and this is the base. So the acids का nature है proton donate करना, base का nature है proton accept करना. So it will accept a proton, resulting in a zwitter ion. Have a look. This becomes NH3 plus because it has accepted a proton, and this becomes SO3 minus because it's donated a proton. So this is the zwitter ion form. Zwitter ion is nothing but when an organic compound has both the positive and negative charges in the same thing, that's called as zwitter ion. Okay, so this is nitration, sulfonation, bromination. Here we finish with the electrophilic substitution properties of aniline.